Let's take a look at the picture here. We're asked to set up a proportion to solve for the segment D if we know that A is 7, B is 4, C is 2. Now, if we take a look at the intersecting chord theorem, now remember, intersecting chords means that you have a segment that goes across a circle and it intersects inside the circle. That's important to recognize. When that happens, we're told that we can set up these fractions where we take one segment from one of the chords and we put it on top of the segment from the other chord. So we do A over C here equals D over B. The beautiful part of this is you can flip-flop these. And it will help you. You still are going to be able to solve the problem. Now our next step then is substitute the values in. We're going to replace the A with the 7, the B with the 4, and the C with the 2. Let's look at what those fractions look like. Now you may be looking at those and really getting those proportions, that's the hardest part. Now you just get to do cross multiplying here. So you're going to go 4 times 7 equals 2 times D. 4 times 7 equals 2 times D, and you get 28 equals 2D. Now if you want to get D by itself, you're going to divide both sides by 2, and you get that D is 14. Now, the hard part, we've said this about geometry 1,000 times. The computations are pretty simple. So in this problem, focus on identifying what kinds of segments you're working with. In this case, they were chords, and that they intersected inside of the triangle so that you can set up your proportion and then solve.